We are going to look at linear models. In linear models, we are looking at trends among data points. We are trying to see how important these trends among data points really are. There are a few things that we are looking for. One is we are looking for a trend. In a trend, you're looking at the center of the model. You're trying to see what it is doing. We're going to talk about strength. Strength is really a measure of how strong the trend is. We're going to look at shape. When we talk about models, we're talking about lines. Lines come in different formats. It could be a straight line. It could be a curved line. It could be an asymmetric line. It could have a lot of different formats to look at. We look at the general tendency of a scatter plot. Remember, we just got through the scatter plot. You had to see how the scatter plot was put together. You're looking at the general tendency. Look at it from left to right. Start on the left-hand side, which is our 0 on the x-axis. Go to the right. If it is positive, we get an increase. It goes upward. If it is negative, it decreases. This diagram shows a negative trend or a decrease. It goes down. As you put a treatment in, it decreases the effect of whatever you're looking at. You could think of positive increases. Put a seed in the soil, put fertilizer on it. You want it to grow tall. It increases over time. You could think about negative, which is decreases. Go back to COVID. What happened as vaccines came out or as vaccination rates went up? The amount of disease started to drop off. That would be a negative effect. Occasionally, there may be associations that are nonlinear. Nonlinear associations are often called polynomial. Strength. Strength looks at the amount of scatter on the scatter plot. In strength, we're trying to figure out variation. The closer together the points are to the trend line, the greater the strength, the less variation there is. Look at this particular diagram. About half the data points are above the line, half of them are below the line, some of them are close to the line, some of them are farther away from the line. In an ideal world, we want it all to be just about right on the line. That would show us a lot of strength. That doesn't always happen. Then we have shape. Shape goes down to, is it linear or is it nonlinear? Nonlinear means you can't define it by a straight line. You've got a constant rate of increase or decrease. Linear things are very common in nature. They are not difficult to evaluate. They're easy to describe. If it's nonlinear in nature, it's more difficult to summarize. It is not easy to calculate. This drawing has got some nonlinear thing. The graphs that are curved are nonlinear. It starts out, it increases, it reaches a maximum, it tapers down. That can be described by a mathematical line. That's a polynomial type line, which means it's not easy to calculate. Also, the data points are scattered all over the place. Some of them are up, some of them are down. Those data points are described by that particular line. On the linear part, we have 2 data points, which means you get a rather easy description of it because 2 data points give you a straight line. When we're looking at shapes, we have shapes that are polynomial. We have shapes that are linear. We have all sorts of different shapes. All of these go back to mathematical calculations that we can use to create a model. We often call these linear models because a lot of them can be described by a line.